Here we are evaluating. This is 10 to the 6th, so it's going to move this decimal place 6 places to the right. So this will be 1, 2, 3, 4, 5, 6. And in these gaps, we put zeros. So this is 519 with 4 zeros behind it. So 5,190,000. On this one, the decimal place is back here, so you're going to move it 4 places to the right. These ones up here, 10 to the 5th, that's a 1 with 5 zeros. This is a digital lesson. So if your teacher has opened it, go ahead and follow along with me. Otherwise, you can just watch the video. It says this geometric pattern is called a Sierpinski triangle. Observe how the number of shaded triangles changes as you press next. So it shows here in step 1 there are 3 shaded triangles. When I hit next, now there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So 3 to 9, that triples the amount. Then 9 times 3 gives me 27. So this next one is going to be 27 tripled. Three times 7 is 21. 3 times 2 is 6, plus 2 more makes 8. So this one will say 81. In this step, it triples again. 81 times 3. 3 times 1 is 3. 3 times 8 is 24. Then we have 243 times 3 for this next step. 3 times 3 is 9. 3 times 4 is 12. 3 times 2 is 6, plus 1 more makes 7. Or 729 shaded triangles. What do you notice about the number of shaded triangles, and what do you wonder about the number of shaded triangles? We noticed that it tripled each time. I wonder if we could continue this pattern for even more triangles. Let's look more closely at the pattern in the Sierpinski triangle. What multiplication expression can you use to find the number of shaded triangles in each step? Write this expression in expanded form. So this would be 3 times 3 times 3. This next one would be 3 times 3 times 3, and then we would triple it again. And the same thing for this one, but with an additional 3. Try that last one on your own. When you multiplied repeated tens to represent place values in previous grades, you used exponents to show the number of tens being multiplied. Complete the table. In here, you can type in 10, and then this little X with the button allows you to type in the exponent, and you want a 3 there because there's 1, 2, 3 tens being multiplied. Same thing. This time there are 4. And for this one, there are 1, 2, 3, 4, 5. So this one allows us to put the exponent of a 5. Based on your answers in the table, use exponents to write this one. The base is the number being multiplied. So in this one, instead of 10 being the big number, we're going to use 3 as our big base. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So our exponent will be 10. That is not the same as 10 to the third. This says let m be a non-zero whole number. So m is that exponent. And for any number a, where a is the base, the expression a to the m power is the product, meaning multiplying, m factors of a. So we multiply it out as many times as m shows up. In the expression a to the m power, the number a is the base, and the number m represents the exponent. A to the m is called m power of a. And we read it as a to the mth power. So this one would be 10 to the 6th power. In this geometric pattern, it's called a Sierpinski carpet. Use the interactive to complete the table. Here, in the first step, there are 1, 2, 3, 4, 5, 6, 7, 8 shaded squares. In this next one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this section has 24, and this section has 24 for 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. So in expanded form, this would just be 8. And in exponential form, this would be 8 to the first power, because that's step 1. In expanded form, this would be 8 times 8. And in exponential form, we would write it as 8 to the second power, because there are two 8s being multiplied together. For step 3, we would multiply another 8 in there. So we'd say 8 times 8 times 8, and this would be 8 to the third power. If we did 64 times 8, that would tell us what number goes here, which is 512. What do you think the expanded form of the number of shaded squares in step 7 of the Sierpinski's carpet would be? Well, it would be 8 written out 7 times. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then the exponential notation would say 8 to the 7th power. And explain how you know. The step indicates the exponent, and the 8 represents the base. For this slide, you're going to be writing them in exponential notation or an expanded form. Go ahead and pause here so you can try them out and then come back and check when you're done. Oh. So option 1 is you receive $2 on day 1, and each day for the next 14 days you receive $2 more than the amount of money that you received the previous day. Option 2 is that you receive 2 cents on day 1, and then each day for the next 14 days you receive double the amount of money that you received on the previous day. So think about the way the money is growing before just making a quick decision. Even though you start with more money on day 1 in option 1, do you end with more money by day 15? Make a selection, and then we're going to look at the next couple of slides to see if you made the right choice. Here we see in option 1, it's growing by $2 every day. And in option 2, it's doubling each time. And then towards the end, it starts doubling, and it looks a lot higher than the money in option 1. Here it asks us to look at the amounts more closely. So this would go 2, 4, 6, 8, 10, 12, 14, 16, 18, because it's increasing by $2 each time. But this one is doubling each time. So if I double 8 cents, that would be 16 cents. Then 32 cents. 32 times 2 would be 64. 64 times 2 would be $1.28. If I double 128 times 2, that would give me $2.56. If I multiply that by 2, that would be $5.12. $5 doubled would be $10. 12 cents doubled would be 24 cents. If I double $10, that's $20. And if I double 24 cents, that's 48 cents. 20 times 2 is 40, and 48 cents times 2 is 96 cents. $40.96 doubled would be $81. $1,092.92. And if I double that or multiply that by 2, I get $163.84. And then if I double that or multiply that times 2, that would give me $327.68 for the last day. So you can see it grows really fast here from 2 cents all the way up to $327. So now it says, do you want to change your choice now that you have more information? Why? Option 2 definitely seems better now. You can see that up through day 12 or day 11, that option 1 has more money for that day. But at day 12, option 2 starts leading with $40. So in the beginning, option 1 would be better. But by the end of day 15, option 2 has grown so fast that it would be the better option. So here's your original choice, and here's the changed choice. And then it will also show other students in our class. So we might have some people who chose option 1 in the beginning, and then who switched to option 2. Here are 2 new options. Would you rather you receive $2 on day 1, and each day for the next 5 days you receive double the amount of money that you received the previous day? Or you receive $10 on day 1, and each day for the next 5 days you receive 10 more than the amount of money that you received on the previous day. So let's do a 5-day model and see which one would be better. On the first day, we would get $2 in option 1, and then we would double, so that would be 4, 8, 16, and 32 for the first 5 days. And then we would also need 64 because there's the first day and then the next 5. For option 2, we start with 10, and then the next day we would get 20, 30, 40, 50, and 60. There's the next 5 days. If we were to find the total here, 10 plus 20 is 30, plus 30 is 60, plus 40 is 100, 150. This would be 210. Over here, 2 plus 4 is 6. 6 plus 8 is 14. 14 plus 16 is 30. 30 plus 32 would be 62. And 62 plus 64 would be 126. So when it's a short amount of time, option 2, where you receive more money each day, is better than doubling. It says, without using a table, how can you find the amount of money you receive on day 6 for option 1 and for option 2? Well, for option 1, that would be 1, 2, 3, 4, 5, 6 times. So for option 1, we could use 2 to the 6th power to figure out how much money we would get for day 6. For option 2, we would just multiply 10 by 6, because that gives us 60. Without evaluating, determine which statement is true. Is 7 to the third power greater than 3 to the seventh power? Smaller than or equal to? Well, let's just write it out. Not evaluate it, just write it out. Now, this is going to grow pretty quick. But because there's so many of them, just like doubling each day, this appears like it's going to grow even faster. So then, since this is growing so rapidly, we would say that 3 to the seventh is bigger and 7 to the third is smaller. Now it says evaluate. Did you make the right choice? Well, this would be 7 times 7 is 49. And then 49 times 7 is 343. This one would be 3 times 3 is 9. 3 times 3 is 9. 3 times 3 is 9. And then we have another 3. 9 times 9 is 81. And 9 times 3 is 27. 81 times 27 is 2,187. So did we make the right choice? Yes, 3 to the seventh is bigger. Let's look at other ways we can use exponential notation to express numbers. List multiplication sentences that equal 40 by using whole numbers. You may use more than 2 numbers. Well, 4 times 10 is 40. 2 times 20 is 40. 2 times 2 times 10, because 2 times 2 is 4, and 4 times 10 is 40. We have 8 times 5 is 40. That could be the same as 4 times 2 makes 8, and then times 5 would make 40. We could also do 2 times 2 is 4. 4 times 2 is 8. And 8 times 5 is 40. Then it says, how could you use exponents to write 5 times 2 times 2 times 2? Well, 5 is only written once, so we would write 5 to the first power, 5 to the first power, times, then we have 2 is written out 3 times, so 2 to the third power. Here, 3 is written once. There's an invisible exponent of 1 next to this 3. And then we have 2 times 2 times 2 times 2. So there's 4 of them, so it's to the fourth power. Write the prime factorization of each number. That means the smallest pieces you can break it into. 100 is 10 times 10. But 10 can be rewritten as 5 times 2 And this 10 can be rewritten as 5 times 2. There's 2 5s and 2 2s. So that would be 5 to the second power times 2 to the second power. 72 is 8 times 9, but 8 can be broken down into 4 times 2, and 9 can be broken down into 3 times 3. 4 can be split up again into 2 times 2. So I have 2 to the third because there's 3 of them, times 3 to the second because there are 2 3's shown here. 80 could be 8 times 10. We can split up that 8 into 4 times 2, and the 4 can be split into 2 times 2. 10 can be split into 2 times 5. So that would be 2 to the fourth power times 5 to the first power, but we can make that one be an invisible one. 63 is 7 times 9. 9 can be split up into 3 times 3, but 7 cannot be split up any further. It is a prime number. Please make sure that any notes you need for this lesson are written down, and then that your composition book for your warm-up is finished as well.